Tonight, an asteroid roughly the size of a football stadium will pass within 2 lunar distances of Earth. That is under 500,000 miles, close enough that orbital trackers flagged it months in advance, and close enough that, on a cosmic scale, it counts as a near miss. Nothing is going to hit us. But the reason this object matters has almost nothing to do with tonight, and everything to do with what it reveals about the objects we have not found yet. In the next few minutes, you will understand exactly why an object this size, moving this fast, at this distance, is being tracked in real time by government space agencies, and what it tells us about the much larger blind spot still sitting out there in the dark. Here is the single most important thing to understand before anything else. Distance in space is not the same as distance on Earth. 2 lunar distances sounds close because we anchor it to the moon, something we can see with our own eyes. But 2 lunar distances is still roughly 480,000 miles. That is comfortably safe. No agency is issuing an alert. No orbital model shows any chance of impact. So why does an object like this get a name, a designation, a tracking file, and international attention? The answer is size and speed, not proximity. An asteroid in the 100 to 200 meter range, stadium-sized, travels at velocities that can exceed 10 miles per second. At that speed, mass becomes energy in a way that is difficult to intuit. A rock that size, striking at that velocity, would not create a crater. It would create a regional catastrophe. That is the category this object falls into, even though tonight it poses zero risk. It is being watched because objects of this exact size class are the ones most likely to slip through detection until the final weeks before a close approach, and that is the uncomfortable part of the story. Consider the mechanism behind why we only just found this thing. Space agencies do not track every rock in the solar system. They track the ones bright enough and positioned favorably enough for ground-based and space-based telescopes to catch. Objects this size are faint. They do not reflect much sunlight, and depending on their orbital path, they can approach from the sunward side of the sky, the one direction our telescopes are structurally worst at watching, because you cannot point a telescope at the sun. That is why an asteroid can go from undetected to catalogued in a matter of weeks, sometimes days, even when it turns out to pose no danger at all. The detection lag is the real story. The flyby itself is almost incidental. And that brings us to the historical case study that changes how seriously people take nights like tonight. February 2013, Chelyabinsk, Russia. A meteor roughly 20 meters across, a fraction of the size of tonight's object, entered the atmosphere without warning. No agency saw it coming. It detonated roughly 15 miles above the ground, with the force of nearly 30 Hiroshima-scale explosions, and the shockwave shattered windows across 6 cities, injuring over 1,600 people, mostly from flying glass. That object was small enough to be functionally invisible to the monitoring systems of the time. Tonight's object is roughly 5 to 10 times larger. If something that size entered the atmosphere instead of passing by, the outcome would not be broken windows. It would be a regional-scale airburst capable of leveling structures across dozens of miles, similar in some estimates to the Tunguska event of 1908, which flattened roughly 800 square miles of Siberian forest. Connect that back to tonight's flyby. This is not a doomsday warning. It is a demonstration of exactly why an object this size, this close, gets logged, time-stamped, and modeled by every major planetary defense program on Earth. Now, bring that back to the conspiracy angle, because it always surfaces on nights like this. Search engines fill up with claims that agencies are hiding the real size, that a flyby this close is being downplayed, or that governments track these objects secretly and only release the ones deemed harmless. Here is the actual answer, and it is far less dramatic than the theory. Close approach data for objects like this is public. It comes from catalogs maintained by international tracking centers, cross-referenced by independent astronomers and amateur observatories around the world. many of whom publish their own measurements within hours of major agencies. If a genuinely dangerous object were on an impact trajectory, it could not be quietly suppressed. Too many independent parties are watching the same coordinates. The concerning truth is not concealment. It is coverage gaps. We are not hiding the threats. We are missing them, because the survey systems that exist right now still have not catalogued the majority of objects in this size range across the entire solar system. That is the number that should actually stay with you tonight, more than the 2 lunar distances. Estimates suggest that less than half of near-Earth objects in the 50 to 300 meter range have been found and tracked. That means the object approaching tonight is one of the ones we caught. The ones we have not caught are, by definition, the ones we are not watching for at all. That is the quiet dread underneath a story that otherwise sounds routine. Tonight is not the risk. Tonight is a preview of the kind of object that occasionally arrives with almost no warning. And the gap in our catalogue is the actual hazard, sitting patiently, waiting for its own version of this news cycle to happen without warning. Waiting for its own version of this news cycle to happen without warning. So let's talk about what tracking an object like this actually involves. Because the process itself explains why some flybys make headlines while others, arguably more dangerous, pass by completely unremarked. When an object is first detected, observatories calculate a preliminary orbit from a short arc of observations, sometimes only a handful of nights of data. That preliminary orbit carries wide uncertainty. As more observations come in, the uncertainty narrows, and within days to weeks, an object's trajectory can go from a wide range of possible outcomes to known safe passage with extreme precision. That is why some objects get discovered, flagged with brief concern, and then quietly cleared within a news cycle. It is not that the danger disappeared. It is that the uncertainty collapsed, and the math simply confirmed what was likely all along. A miss, not a hit, but here is where it gets more serious, and where this particular size class earns its reputation. For objects under 50 meters, an early miscalculation is low stakes. Worst case, a local airburst like Chelyabinsk. For objects over 1 kilometer, the world's major sky surveys have already found the overwhelming majority, because objects that large are bright enough and their gravitational influence detectable enough that almost none remain hidden. The genuinely under-monitored middle ground is exactly where tonight's object sits. Large enough to cause continent-scale devastation on impact, small enough to stay hidden until weeks, sometimes days, before a close approach. That is the population planetary defense scientists refer to when they talk about the detection gap, and it is the reason an object passing at a perfectly safe 2 lunar distances still generates urgent tracking requests, follow-up observation campaigns, and refined orbital modeling before it has even left our neighborhood. Here is the single most important thing to take from that. Proximity tonight is not the threat. Population of undiscovered objects in this size range is the threat, and that population does not go away when this asteroid passes by tomorrow morning and fades from headlines. It is still out there, unnamed, unlit, unfound, following whatever orbit brought it into existence billions of years ago, waiting for a survey telescope to finally catch its reflected light on some future night that will not be scheduled or predicted in advance. So here is what actually matters going forward, distilled into what you should watch for in the weeks and months after tonight. Number 1. Watch for follow-up designation updates. When an object like this is first announced, it often carries a provisional name. Within days, refined orbital data either confirms long-term safety for the coming decades or, in rare cases, flags a future close approach that warrants continued monitoring. That update matters more than tonight's flyby itself. Number 2. Watch impact probability tables published by Planetary Defense Monitoring Systems. These are ranked lists of newly discovered objects with any statistically non-zero chance of future impact. The vast majority start with a small non-zero number and drop to 0 within days as more data comes in. It is very rare for a number to climb instead of fall. But when it does, that is the signal worth paying attention to, not the initial announcement. Number 3. Watch survey funding and infrastructure news. New space-based infrared telescopes, designed specifically to catch the object's ground-based systems miss, are the actual solution to the detection gap. Delays or expansions in that funding directly translate into how many more years remain before this size class becomes fully catalogued. Number 4. Watch for follow-up observations from independent amateur networks. In an era where speed matters, distributed observation confirms official tracking data quickly, and discrepancies between independent and agency data are themselves worth noticing. Connect all 4 of those back to the object passing tonight, and the picture becomes clear. This is not an isolated event. It is a single visible data point in a much larger, mostly invisible population. A preview of the exact category of object our detection systems are still racing to complete. So where does that leave us? Tonight's asteroid will pass safely, quietly, and by tomorrow it will already be moving away. Its orbit refined, its risk reduced to essentially zero for the foreseeable future. But the system that caught it, the network of telescopes, calculations, and public catalogs that turned an anonymous rock into a tracked, understood object, is still incomplete. Somewhere out there tonight, another object in this same size range is following its own path, unlit by any telescope, unlisted in any catalog, on a trajectory nobody has calculated yet. That is not a reason for panic. It is a reason for infrastructure, funding, and attention, sustained long after tonight's headlines fade. Watch the catalog, watch the funding. Those 2 things, more than any single flyby, will determine how much warning we actually get next time. If this kind of explainer helps you understand the world a little more clearly, subscribe for the next one. These threats do not stop being relevant just because tonight's object safely passed by. Like the video if you want more of these deep dives into the forces most people never think about until it is too late, and share it with someone who still thinks these flybys come out of nowhere. They do not. We are just still learning how to see them coming.